This is the view out looking forward along where the shadow of the LEM is cast on the surface, and we see a zero phase glow around the upper portion of the LEM. The general color of the terrain looking down sun was a very light tannish color. This blended as we look more across sun to a more sharper, well-defined features and more of a gray color. During the initial time period after touchdown, we went through various sequences to prepare us for immediate abort or liftoff if we found that that was necessary. We found we had to vent the fuel and oxidizer manifolds a good bit earlier than we had thought. We went through these various checks and prepared for one liftoff that would occur about 21 minutes after the beginning of powered descent. The ground gave us a stay during this period. We did not have to make use of that. We then proceeded at that point into our simulated countdown, which consisted of checking our guidance systems. We made use of a gravity align feature where the inertial platform of the primary guidance would use the gravity vector to determine the local vertical. We would then compare this with the alignments that we had previously. We also made use of the stars through the telescope and aligning a crosshair by rotating the field of view until the crosshair superimposed on the star. This would give us the angular measurement of the star within the field of view of the telescope. We then determine the distance out by aligning another reticle spiral on this. We went through an averaging technique on board and then fed this information into the computer, and this came up with our various alignment checks. This was all in preparation for a possible liftoff that would occur about 2 hours after touchdown as Mike and Columbia came over for the first revolution. The ground network gave us a stay, and we continued briefly through the remainder of this checklist in our simulated countdown. And at this point, we terminated and powered down many systems on board the spacecraft and went into an eat period.
A number of experts had, prior to the flight, predicted that a good bit of difficulty might be encountered by people attempting to work on the surface of the moon due to this variety of strange atmospheric and gravitational characteristics that would be encountered. This didn't prove to be the case, and after landing we felt very comfortable in the lunar gravity. It was, in fact, in our view, preferable both to weightlessness and the Earth's gravity. This led us to believe, this in conjunction with the fact that all the systems in the LEM were operating magnificently and we had very few problems, to go ahead with the surface work immediately. We predicted that we might be ready to leave the LEM by 8 o'clock, but those of you who followed on the ground recognize we missed our estimate by a good deal. This was due to a number of factors. One, we had house cleaning to perform, food packages, flight plans, and all the items that we had used in the previous descent to be stowed out of the way and prior to depressurizing the lunar module. It took longer to depressurize the lunar module than we had anticipated, and it also took longer to get the cooling units in our backpacks operating than we had expected. In substance, it took us approximately an hour longer to get ready than we had predicted. when we actually descended the ladder, it was found to be very much like the lunar gravity simulations we had performed here on Earth. And no difficulty was encountered in descending the ladder. The last step was about 3.5 feet from the surface, and we're somewhat concerned that we might have difficulty in re-entering the LEM at the end of our activity period, so we practiced that before doing the exercise of bringing the camera down, which took the subsequent surface pictures. Here you see the camera being lowered on what might be called a Brooklyn clothesline. I was operating quite carefully here because immediately to my right and off the picture was a 6-foot deep crater, and I was somewhat concerned about losing my balance on those steep slopes. The other item of interest in the very early stages of EVA, should it have been cut short for some unknown reason, was the job of bringing back a sample of the lunar rocks. And these photographs show the collection of that initial sample into a small bag, and then that bag being deposited in my pocket. This was the first of a number of times when we found two men were a great help. I quickly put up the TV camera. And then, more leisurely, Buzz and I joined together to erect the American flag. We found on a number of occasions that we were able to help each other in many ways on the surface. You probably recall the times that I got my foot caught in the television cable, and Buzz was able to help me extract it without falling down.
We had some difficulty at first getting the pole of the flag to remain into the surface. In penetrating the surface, we found that most objects would go down about 5, maybe 6 inches, and then it would meet with a gradual resistance. At the same time, there was not much of a supporting force on either side, so we had to lean the flag back slightly in order for it to maintain this position. So many people have done so much to give us this opportunity to place this American flag on the surface. To me, it was one of the prouder moments of my life to be able to stand there and quickly salute the flag.
The rest of the activity seemed to go very rushed. There were a lot of things to do, and we had a hard time getting them finished.
We did find that mobility on the surface was, in general, a good bit better than perhaps we had anticipated it. There was a slight tendency to be more nearly toward the rear of a neutral stable position. Balance seemed to be quite easy to identify, and as one would lean a slight bit to one side or the other, it was very easy to identify when this loss of balance was approaching. In maneuvering around, as you saw, this was one of my tasks fairly early in the EVA. I found that a standard loping technique of one foot in front of the other worked out quite well, as we would have expected. One could also jump in more of a kangaroo fashion, 2 feet at a time. This seemed to work, but without quite the same degree of control of your stability as you moved along. we found we had to anticipate 3 to 4 steps ahead in comparison with the 1 or 2 steps that are ahead when you're walking on the Earth.
We had very little trouble, much less trouble than expected on the surface. It was a pleasant operation. Temperatures weren't high, they were very comfortable. The little EMU, the combination of spacesuit and backpack that sustained our life on the surface, operated magnificently. We had no cause for concern at any time with the operation of that equipment. The primary difficulty that we observed was that there was just far too little time to do the myriads of things that we would have liked to have done. In the pictures we showed earlier, you saw rocks in the boulder field out Buzz's window that were 3 and 4 feet in size, very likely pieces of the lunar bedrock. And it would have been very interesting to go over and get some samples of those. There were other craters that differed widely that would have been interesting to examine and photograph. And we had the problem of the 5-year-old boy in a candy store. There are just too many interesting things to do. The surface, as we said, was fine-grained with lots of rocks in it. It took footprints very well, and the footprints stayed in place. The LEM was in good shape and exhibited no damage from the landing or the descent. It's a picture of the ladder with the well-known plaque on the primary strut. There was a question as to whether the LEM would sink in up to its knees. It didn't, as you can see. The footpad sunk in perhaps an inch or 2. And the probe in this picture was folded over and sticks up through the sand in the bottom right-hand corner, showing that we were indeed traveling slightly sideways at touchdown. There were a wide variety of surfaces. Here Buzz is standing in a small crater, and it gives a very good picture of the rounded rims of the what we believe are very old features. The LEM was in a relatively smooth area between the craters and the boulder fields, and we had some difficulty in determining just what straight up and down was. Our ability to pick up straight up and down was probably several degrees less accurate than it is here on Earth, and it caused some difficulty in having things like our cameras and scientific experiments sometimes not maintain the level attitude we expected.
The 2 experiments that you saw in the previous picture were deployed in the scientific equipment bay. We found that getting them down produced no significant problems. And here you see a view of Mike carrying these 2 experiments out to the deployment site about 70 feet to the south of the lunar module. You have a very good view of the varying depths of this upper surface layer. You see that along the crater rim, the small crater rim off to my left, along this the upper surface appears to be about 2 to 3 inches, and the subsurface has a slope that is rather ill-defined, and one has to be very careful in threading your way around these very small craters. Any long excursions, I feel, would take a good bit of attention as you're moving along to avoid walking along or down the slope of some of these smaller craters. This is the passive seismic experiment that was deployed and has been giving us good returns on the interactions of the moon. We had a little difficulty deploying one of the panels. I had to move around to the far side and release a restraining lever, and then the second panel came out. We had a little bit of difficulty determining, as Neil said, the exact local horizontal. And I think this is due to the decrease in the cues that a person has as to which way up really is. One has to lean a little bit more off to the side before you get this body cue that you're approaching.
Landmarks that assured us that we were on the proper track. There were no difficulties with the ascent, and we enjoyed the ride more than we could say.
Both guidance systems agreed very closely when we were finally inserted into orbit. I believe there was something on the order of a half a mile or 7/10 of a mile difference in the apogee in the resulting orbit. Following an alignment check after insertion into orbit, we proceeded with gathering radar data of relative positions between the two vehicles. The solution for the first sequence of rendezvous maneuvers was extremely close and agreed very closely with the value that the ground had given us. The surprising feature of this rendezvous, many of us were expecting a fairly large out-of-planeness due to perhaps some misalignment in azimuth on the surface. We were expecting somewhere up to maybe 20 or 30 feet per second out-of-plane velocity. We found that we didn't even have to make use of a particular out-of-plane maneuver that had been inserted between two other sequential maneuvers. In comparison with many simulator runs, we found that this was about as perfect a rendezvous as we could have asked for.
You've noted some oscillations in this film during ascent, and that's a real characteristic. The vehicle, due to the changing center of gravity as fuel is used, does a good bit of 5-degree oscillations throughout the ascent.
Just as eagle is seen by Columbia, or perhaps half an eagle would be better, since the landing gear and lower part, the descent stage, of course, remained on the surface. This was a very happy part of the flight for me. I, for the first time, really felt that we were going to carry the thing off at this stage of the game, and it looked like although we were far from home, we were a lot closer to it than the pure distance might indicate. Neil's making the initial maneuvers here to get turned around, and then again I do the final docking. This is somewhat swifter than real time. The probe, the dark funnel on the top of the LEM, and the docking target below it and to the left in the lighter portion of the LEM. As Buzz said, the rendezvous was absolutely beautiful. They came up from below absolutely as if they were riding on rails. There was absolutely no disturbance or any off-nominal effects during the last part of the rendezvous. Upper right, you can see the RCS quads, and down below the various antenna and other protuberances. This gives you some idea of the rough terrain available on the moon. Of course, the Maria on the front side are smoother than this, but in general, the back side of the moon is quite rough. And I have, in general, just a series of slides, which, in the interest of time, I'm not going to dwell on. But I just like to point out that we did take a number of pictures. I believe from Columbia we took probably 1,000 stills, and some of them show very interesting surface features, various types of unusual craters, and some of them pose many riddles, which we hope the geologists will in time be able to answer for us. that line of craters, for example, is difficult to explain, or at least without an argument it is. A newer crater with the white material having come from it. And this is a picture of the solar corona. Neil, would you like to close with that?
During our flight to the moon, we flew through the moon shadow. In fact, the moon was eclipsing the sun, and we took the opportunity to try to take some photographs of it, but our film was just not sufficiently fast to capture the event. However, this does show the brightest part of the solar corona. It extends several moon diameters in addition on each side. They're roughly parallel to that light. But the striking thing to us as observers was not the solar corona, but the moon itself. Of course, it was dark, unilluminated by the sun, but it was illuminated by the Earth. And at this relatively close range, it had a decided three-dimensional effect, and was undoubtedly one of the most impressive sights of the flight. As we left the moon after a successful TEI, this is the view that we observed. I think that, at least from where I sit here on the stage, the colors that you see there are quite close to being actually representative of the moon as seen from that distance. We were sorry to see the moon go, but we were certainly glad to see that Earth return. We took a large number of photographs of the Earth on the way out and back, and had our wristwatches set on Houston time. An interesting use can be made of that. If you were looking at this picture and you looked at your watch and your watch said 7 o'clock in the evening, then you'd know that Houston is about 7 o'clock from the evening, and it's about an hour away from sunset, so it would be about 1/24th of an Earth's circumference away from the shadow, which is just about 15 degrees there. So at any time, by looking at a wristwatch and looking down at the Earth, we knew what was underneath the clouds, and it aided us in some ways in picking out what we should be seeing. We could see a large number of details on the Earth's surface, certainly all the continents and islands and details, many of which you followed perhaps in our discussions over the radio communications, but it was interesting to us to find out how well we could observe weather patterns on not only the worldwide scale, which you see here, but in specific localities. This particular shot does show the coast of North America, the equatorial cloud layers, what we think is probably an intertropical convergence zone, and cirrus clouds over the Antarctic.
We're ready now for question and answers, and wait for the microphone, and we'll go right down the line, and we'll catch everyone if you'll just be patient. Tom will too.
How much time did you have left in your life support backpacks at the time you got back on board LEM?